Good morning all. So in today's class we will see a few more problems on multisets. So the first question is, show that 4n factorial is a multiple of 2 raised to 3n into 3 raised to n for each natural number n. So we need to show that 4n factorial is a multiple of 2 raised to 3n into 3 raised to n for each natural number, or if we can show that 4n factorial by 2 raised to 3n into 3 raised to n is an integer, then or if it is a whole number, then we can say that 4n factorial is a multiple of 2 raised to 3n into 3 raised to n. We'll show that this is a whole number. Okay, so that will give the proof. Now for this proof, so let us consider the multiset. So consider the multiset 4a1, 4a2, 4a3, etc. 4an. So this is a multiset of n objects a1, a2, etc. an. So where each object is repeating 4 times. So a1 is contained 4 times, a2 is contained 4 times, so on an is contained 4 times. So total there are 4n objects. So now let us consider the permutation P of 4n, then 4, 4, etc. 4. So here this is coming n times. So this is the number of permutation of 4n objects, where object A1 is repeating 4 times, A2 is repeating 4 times, and AN is repeating 4 times. So this is the number of arrangements where each object is repeating these many times. So by definition, this will be equal to P of R, R1, R2, etc. Rn. So R1 is of type 1, R2 is of type 2, and Rn is of type 1. And when you take R1 plus R2 plus etc. Rn, so that will be equal to R. So by the formula permutation, so this will be equal to 4n factorial by 4 factorial, 4 factorial, etc. 4 factorial varum. So that will give you 4n factorial by, this is 4 factorial whole raised to n. Ini namakku 4 factorial nu that is 4 into 3 into 2 into 1. So that is 8. 8 എന്ന് പറയുന്ന 2 cube varum. So 2 cube into 3. So this can be written as 4n factorial by, so 4 factorial ne eniki 2 cube into 3. So annu ezhudan pattum. So whole raised to n varum. So that will be equal to 4n factorial by 2 raised to 3n into 3 raised to n. Now by P of 4n, 4, 4, extra 4, this means that is number of permutations. Of the number of permutations, and that is number of arrangements, this has to be a whole number. So therefore since P of 4n, 4, 4, extra 4 is a whole number, so that implies 4n factorial by 2 raised to 3n into 3 raised to n is a whole number. So that implies, so therefore we get a proof. So 4n factorial is a multiple of 2 raised to 3n into 3 raised to n. So that is the required proof. So let us see a similar problem. So prove by a combinatorial argument that the following number is always an integer for each n belongs to n. So we need to prove that the following number is always an integer. So the number is 3n factorial by 2 raised to n into 3 raised to n. So for this, the problem consider. So here we need 3n. So consider the multiset. 3 factorial 3 factorial will be 3 into 2. So we will take the multiset 3a1, 3a2, etc. 3an, and then take p of 3n, 3, 3, etc. 3. So this is coming n times. So by definition, that will be equal to 3n factorial by 3 factorial into 3 factorial n times. So that is 3n factorial by 3 factorial whole raised to n. So that is 3n factorial by 3 raised to n into 2 raised to n. So since p of 3n, 3, etc. 3 is an integer. So 3n factorial by 3 raised to n into 2 raised to n is also an integer. So that is the required proof. And now, so this was an example of permutation where the objects are repeated. So you have total R objects, and out of R objects, few are repeating R1 times, R2 times, etc. Rn times. So this is the number of arrangements where the objects are repeating. Now let us look at the number of permutations where the objects are repeating. അപ്പോൾ നമുക്ക് objects repeat ചെയ്യുന്നുണ്ട്, പക്ഷെ നമുക്ക് combinations ആണ് വേണ്ടത്. So let us look at what are the number of combinations when objects are of the same type. So let us define first what we need to find. Okay, so let m equal to infinity dot a1, infinity dot a2, etc. infinity dot an be a given multiset where n belongs to n. Then a multiset of the form m1a1, m2a2, etc. mn an, where mi's are non-negative integers is called an m1 plus m2 plus etc. mn element multiset of n. And now for any non-negative integer r, let us define h n r. So let h and r denote the number of r element multi sets of m. So h and r will denote the number of r element multi sets of n. So for example, if you have so let m is equal to infinity dot 1, infinity dot 2, infinity dot 3, infinity dot 4. So you have a multi-set which is containing the elements 1, 2, 3, 4. So each object can be repeated any number of times. So if I want to find h and r, so here let me take h43. So h43 denote the number of all three combinations of the 4 objects where repetition is allowed. So hn4 denotes the number of 3 combinations of 4 objects where repetition is allowed. ഇനി നമ്മൾ യൂഷ്വൽ 3 combination എടുക്കുകയാണെങ്കിൽ, so if you have 4 objects, the usual 3 combination, ഇപ്പോൾ 1, 2, 3, 4 എന്ന് പറഞ്ഞ് നമുക്ക് 4 elements ഉണ്ടെങ്കിൽ repetition ഇല്ലാതെ നമുക്ക് കിട്ടുന്ന combination എന്ന് പറയുന്ന 4C3 ആണ്. So that is 4 factorial by 3 factorial into 1 factorial. So you are going to get only 4 combinations. ഇനി when you are taking the number of 3 combinations with repetition allowed, you will get more number of combinations. So repetitions are allowed. അപ്പോൾ എനിക്ക് 3 combinations ആണ് വേണ്ടത്. Okay, so I can have 1, 1, 1, then I can have 1, 1, 2 വരും, then 1, 1, 3. Now for example I can have 1, 2, 2, then all can be 2, 2, 2, then I can have 2, 2, 4, so on. There are many number of combinations. So h43 denotes the number of 3 combinations of 4 objects where any number of repetitions is allowed, or where infinite repetition is allowed. So in general, when you take h and r denotes the number of ways of choosing r objects out of n objects where any number of repetitions are allowed. So in the next session we will look at how to find the formula for h and r.